Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we've got another viewer-requested topic today. Here it is. Implement user security in the Micro OCS. Well, unlike the Canvas and Excel Prime series, which have a canned user security function built right into them, that is not the case with the Micro OCS, which is more of an entry-level product. However, it's really not all that difficult to build user security functions into your Micro OCS project. And today, we're going to show you how to do that. So without further ado, let's get right to it and break down today's topic. All right, let's start out by answering the question, what do we mean by user security? Then we'll talk at least briefly about how user security is handled in the Excel Prime and Canvas that have that canned user security feature. And then we're going to show you an example approach of how you can build your own user security functionality in the Micro OCS that approximates a fair amount of the functionality that's built into Excel Prime and Canvas. And there'll be plenty of demonstrations throughout. Here we go. So what do we mean by user security? Well, I'm defining user security as the process of controlling access to certain machine operations to authorized personnel only. In other words, if there's a function that needs to be performed by the operator, you want to make sure that it's an authorized and trained operator that's performing that function. Okay, so in practice, how would you keep an operator from performing an unauthorized function? Well, one way would be to prevent them from accessing a screen from which that function is performed. Another way would be to allow them access to the screen, but prevent them from, pressing the button that would actually make the adjustment to the machine that they don't know how to do, maybe start the machine if they really shouldn't be doing that, those sorts of things. Now, the way that an operator would prove their credentials would be for them typically to either enter in a password or maybe enter in a username and a password. And at that point, then the OCS would know, hey, this particular operator, or at least the one that entered this password or has this set of credentials, they should be able to switch to this screen, or they should be able to press this push button and cause this action to occur. So that's what we're talking about when we talk about user security. Now, as I've mentioned already, the Excel Prime and Canvas OCS have a canned user security capability built into them. Okay, if you're using Cscape 10, which you should be by now, it's a great product. You can access this from the User Interface tab, then by pressing the User selection from the System setting. If you're still using Cscape 9.9, you can access User Security Configuration. You'll just have to go to the Graphics Editor, and then under Config, select User Security Configuration. Okay, let's go through an example of how in the Excel Prime or the Canvas, you might protect access to a particular screen. That would be one way you could keep operators from doing something they really shouldn't. Okay, so the first step in the process is to create username and password combinations that have a corresponding access level. Now, what is an access level? Well, it's 8 potential different levels of access, where 0 is the lowest level and 7 is the highest level. All right, and you can set those levels pretty much the way you want. If you only need a couple different of access levels for a project, you could set it up that way. If you wanted to take advantage of all 8 levels, you could do that as well. But once you've entered in your username and password credentials, next you're going to want to place, in order to protect a screen at least, you're going to want to place a jump button on the screen. Okay, and then when you configure that jump button, you're not only can configure the screen it jumps to, but also you're going to press the access button and set the access level for that jump button. In my example here, as you can see from step 4, I've set the access level to 2. So what that would mean is that anybody at runtime who presses this button would have to have an access level of 2 or higher in order for that button to operate. Okay, so that's effectively the way you set up Cscape to protect a screen using the user security function. Now at runtime, what's going to happen is the operator is going to press the button to attempt to jump to that screen, and then he'll get a pop-up window that will ask for username and password credentials. Once he's entered his username and password, if the access level assigned to those credentials is high enough, the screen switch will occur. If the access level is not high enough, he'll see an access denied message instead. So that's the way that you can protect screen access at runtime using the CAN security feature in Excel Prime and Canvas. However, that security feature can do much more than that. It can also be used to protect any object that has an action to it, whether that be a jump button like we've just described, or maybe a push button, or maybe an editable numeric data field, which might be used in a particular application, let's say to adjust the set point on a machine. You don't want everybody necessarily to be able to do that, so by setting an access level to that particular editable data field, that might make some sense in your application. And then there's some other things you can do with the user security feature, and that is you can continuously monitor and record the operators that are logging in and logging out. That could definitely be useful. You can set an automatic timeout so that if a user doesn't press the screen for a set amount of time, he's automatically logged out. Okay. The other thing that's possible, if you're worried about, being able to change credentials, after the fact. So if you have a particular need to change a password or to change a username, you have the ability with this canned feature to be able to make those changes on the fly by assigning variables to those user credentials instead of just hard coding them in Cscape. So plenty of security capability in Excel Prime and Canvas. So now let's talk about how we can incorporate some of these security functions into the Micro OCS, which does not have a canned user security function. And I'm going to show you how you can build a project that has the ability to provide password entry for an operator and automatically log that operator out if there's a level of inactivity. I'm going to show you how to protect against an operator accessing a certain screen. I'm also going to show you how to protect against an operator pressing start buttons and editing numeric data fields if they don't have the appropriate security level. And the way we're going to accomplish that is by utilizing the password object, which I'll describe here in a minute. We're also going to use something called graphic object display attributes, along with some logic, to make all this happen. All right, let's start with the password graphics object. What is it? Well, the password graphics object is basically another numeric entry object. Okay, what's special about it is that even though it behaves just like a regular editable numeric entry object assigned to a double integer variable, during and after data entry, only asterisk characters are shown on the screen. So in other words, while it's in use, while the password is being entered, there's only asterisk being shown on the screen. So if somebody is peeking over the shoulder of the operator, it's much more difficult for them to kind of steal the password. So that's the password graphics object that we're going to use in our sample project to allow the operator to enter in a password. Okay, next we're going to protect individual objects and screens for that matter by utilizing the display attribute capabilities that can be assigned to any graphical object. All right. Now, if you are using the Micro OCS and you double click on any graphical object that has an action to it, like a push button or a numeric data field, for instance, you'll notice that there is an attribute button available in the dialog box, even though there isn't an access button like you would have for accessing user security in the Canvas and Excel Prime. But using this attributes button, you can go in and configure a couple of key attributes that are very useful in protecting objects. One is the visibility attribute. Okay, so if you don't even want an object to be visible for an unauthorized operator, you can use the visibility attribute to dynamically make it invisible. There's also an enable attribute that allows you to prevent an operator from pressing a start button, or if they press a start button, nothing will happen, for instance. Or for editing, let's say, a set point on a numeric data object, so they press that button and nothing happens. So you can also make a object's action, if you will, or its input, if you will, dynamically enabled or not. Now, the way you do this, okay, is first by going into the attributes section of the dialog box and selecting the specific dynamic attributes, or the specific attributes that you want to make dynamic. In my example here, I've checked the visibility attribute by making it dynamic, and I haven't checked the enable input attribute to make it dynamic for this particular object. But you could do either of those or both. And then after deciding which attributes need to be dynamic, then you assign an override variable, which is an integer variable. And then by manipulating the individual bits within that variable, you can make dynamically in your application, you can make the visibility and the input dynamically enabled or not. Okay, the whole rest of today, I'm going to be showing you my example program that I've built with these functions in it that you could use as the starting point for your next Micro OCS project if you want to incorporate user security, or you could just take some of the hints I'm giving you in this logic to build your own from scratch with the exact functions that you prefer to incorporate. All right, let's get started with our example. Let's take a look at what I've implemented in my example project here. So effectively what I've created is 4 different levels of security. I have a not logged in level, I have a user level, I have a maintenance level, and I have an admin level. Okay, so I have 3 different passwords, 1 password for each of the different levels, of course with a not logged in level not needing a password. All right, so what's going to happen is this. These are jump buttons that are used from this main screen to navigate. Okay, so from this main screen, all right, I have 3 different screens created that could be jumped to. Now, it could be 20 different screens. All right, I've just chosen 3 for now for illustration purposes. Now, if you are a user or above, you'll be able to access this user screen. And again, there could be multiple user screens. My example just has 1 user screen. If you are maintenance level or above, you can access any of the user screens and any of the maintenance screens. And if you are admin level, you can access any of the screens. And the way I'm controlling access is by utilizing the visibility attribute on each of these jump buttons. So under attributes here for this jump button, I've assigned the visibility as a dynamic attribute. So if the variable user visible .1, which is the first bit of the user visible variable, if that is a 1, if that's on, then this jump button will be visible. If that first bit is off, then that will be off and that button won't be visible. Okay, so that's how I've incorporated that. For the maintenance screen, as you can imagine, all right, if you go to attributes, okay, the maintenance visibility first bit needs to be on for that to be visible. And in the case of admin, I've created a variable in my attributes called admin visible, and that first bit has to be on for that button, that jump button, to be visible. Okay, now the other thing I've done here with my scheme is I've added a password button here. So this is where the user can enter their password. Now this scheme doesn't implement any kind of username or anything like that. It's strictly a password-based system, all right? So by using this password object, there's a variable in my program called password entry, and that is a double integer, which all password data fields are. The way this data field works, they're always double integer, all right? And that variable will be entered with the password by the operator. But while they're entering it, they'll just see nothing but asterisks, okay? Now, I've also created a logout button that will allow them not only to log in with their password, but to log out manually. And if they don't hit the logout button, I've incorporated some logic that will automatically log them out after 15 minutes. Okay, so that's how I've defined the system. So when an operator goes to this screen, okay, or this screen is displayed, If they haven't logged in, then none of these buttons will be visible, okay, because there isn't a user, a maint, or an admin logged in. Now, if they log in as a user, this will be visible. If they log in as a maint, these two will be visible. If they give a password for the admin, all three will be visible. All right, and then they'll have the ability to jump to the appropriate screens. Okay, now something else that I've also protected, not just protecting access to the screen, but let me go to the user screen to show you some other protections that I've done. Okay, so this is a user screen that either the user, the admin, or the maint category could access. All right, and there's a start button, a stop button, and an indicator light here, along with an indicator of the current temperature and the ability to change the temperature set point. Now, the way this is set up, okay, I've set this up so anybody could start or stop the machine or see that the process is running. That's because I haven't done anything in my attributes to change from the defaults. So anybody can access this particular button, okay, just like I've put no protection at all on it because I haven't. Similarly, to monitor the current temperature, anybody can see the current temperature. As you can see by the fact there's no dotted X on here, there's no visibility attribute or anything else that's dynamic, so anybody can see the current temperature. However, from the standpoint of changing the temperature set point, I have protected that. So if I go to the attributes area on this object, you can see that my enable bit is dynamic. That's the 4th bit here, okay? So I've assigned a integer variable called entry OK, and if the 4th bit of entry OK is on, then whoever is viewing the screen will have the ability to change the temperature set point. If that particular bit is off, then this essentially becomes an object where pressing it does nothing. They'll be able to see what the current temperature set point is, but they won't be able to change it. Okay, so that's how I've configured some of the security features on the screens in this demonstration. Okay, now we've also got some logic that I'm going to show you here in a minute. Okay, so I've got a user access section of my logic. I'm going to go through this here with you in a minute. But before I do that, let's go to the bench and take a look at how this will all work at runtime. All right, so here is my application that's running, and you can see that there are no jump buttons in that center section for screen navigation. That's because nobody is currently logged in. At the bottom, you can see that user, maint, and admin are all just LEDs that are not filled in, so there is no current access level. Also, you can see that that yellow indicator that shows the logout time is at 0. So that means whoever was maybe previously logged in is now fully logged out. So our first step is to enter our password. Now, these passwords have been set to very simple default values, which can be changed. I'll show you that in a little bit. So let's enter in a password. I'm going to enter in the user level password, and when I did that, the user screen pops up, the jump button for that user screen. And notice that I now have a logout time counting down from 15 minutes, and the user level LED has been lit up. Okay, so if I do nothing for the next 15 minutes, it's going to automatically log me out. But if I want to actually go to the user screen right now, I can. So let's do that. Okay, so I can see what the current temperature value is. I can also see what the current temperature set point is. But I don't have the ability to change that set point. That's because I've logged in as an operator, and the operator doesn't have the ability to change that temperature set point because the attribute that controls data entry for that object has been set to do not allow because of the access level. And I'll show you that logic here in a minute. However, as an operator, I could stop the process right now. I could even start it back up again, okay? Because those particular objects that have actions have not been protected. All right, let's go back to the main screen. And now let's log in as an admin. Okay, so first I'm going to log out, and then I'm going to log in as an admin. Okay, and you can see because I'm an admin, all 3 levels are available to me. So if I go back to the user screen, now you can see I do have the ability to make a change to that set point. Okay, and of course I do have the ability to stop and start the process. I also have the ability to go to maintenance. There's nothing on the maintenance screen right now. This is just a demonstration after all. And I can go to the admin. Now, one of the functions I built into this program is the ability for the different passwords for the different levels to be changed by an admin. So you can periodically change these passwords to, obviously prevent you from having to fire up Cscape just to change a password. Also, I've made adjustable the logout time, which is currently at 15 minutes or 900 seconds, but I could adjust that if I wanted again, if I'm an admin. Okay, so that is really the type of system that I have created here. Now you'll notice every time I touch the screen, the logout time resets. Okay, and I'll show you why that is. But basically what we're looking for to automatically log out an operator is for 15 minutes of inactivity, which means 15 minutes of not touching the screen. All right, but of course we can also log someone out by pressing the button. Now we're back in Cscape, and I'm going to show you some of the logic that I've also created here that goes along with the screens that were created to provide this kind of user access capability. All right, the first thing we have here is a series of rungs which make sure that there is a default user password in the system. Okay, so if by default the user password, maintenance password, admin password, and logout presets, if those values are at 0, that's not what we want. We want to make sure there's at least a default value in there for those. So that's what those first few rungs do on the first scan, is they make sure we've got a reasonable value there. Okay, next what we're going to do is look for that password entry variable, the one that's edited through the password object. If that is ever not equal to 0, it means somebody has entered it in. Okay, so if somebody has entered in a non-zero value, we're going to set a one-shot coil to test that password and see if it matches the user password, the maintenance password, or the admin password. Okay, if it does, then we're going to set our admin level, main level, and admin level coils to the appropriate values based on the access level. And then once we've checked the password against the, the possible levels, we're going to clear out that password entry variable. So it's normally sitting there at 0 unless somebody has just entered in a value. Okay. Now, once we have tested to see if the password is valid or not, okay, if we aren't at any level, if a valid user level, maintenance level, or admin level have not been entered, then I'm going to turn on a bit here which displays on the screen a dynamically visible text object which basically says invalid password. Okay, so I'll show you that again here in a minute when we go back to the bench in case I enter in an invalid password. You'll be able to see that work. Okay, and there's a little more logic here along with the timer to make sure that message shows up just for 5 seconds. All right, now we talked about having automatic logout, so here's the logic for this. So basically what that says is if we're currently logged in any level, okay, we're going to have a 15-minute timer by default. You can change it up or down, of course, as I showed. And if that timer expires, then we're going to turn on a coil that's automatically going to cause a logout. And then we've got a ability to calculate the remaining time for that timer so we can display that on the screen so the operator can see that. That could be useful. All right, now how do we reset that timer back to 15 minutes if there's activity on the screen? Well, we do this utilizing one of the system registers, and there's a system register that will show you the X coordinate every time the button is pressed. All right, so as long as there's a non-zero value in the X coordinate, it means somebody is touching the screen. I could have used the Y coordinate instead. I decided to use the X coordinate. So if it's non-zero, the touch is active. And if the touch is active, then we're going to reset our automatic logout timer. So that's how that logic works. Okay. All right. Now, if the logout button is pressed, or if the logout timer expires on its own, we're going to reset the access level. So turn off those bits that were set when the access level was after login, was set after login. We're going to do that, and we're going to move back to the main screen, because if it was a protected screen that was being displayed when the logout timer expires, we want to make sure we go back to a unprotected screen, which is our main screen of screen number 1. Okay, now down here is the logic that we use to dynamically manipulate those visibility bits and entry enable bits for those objects where we use those dynamic display attributes. So if we are at any of the levels, okay, then basically any object which is visible for a user should be visible. Okay, as long as we're logged in any one of these 3 levels, then we should be able to turn this bit on, which should cause the user visible objects to be visible, which in our case is that user screen jump button. Again, if we're logged in at either maintenance or admin, we want the maintenance type objects to be displayed or visible. And at that case, what we've said for this particular scheme, as long as you're at least a maintenance level operator, you'll also be able to enter in changing set points and those sorts of things. So the objects where you want to protect data entry will also be enabled if you're at least of the maintenance level. And then if you're of the admin level, then the admin visible objects, which are basically the admin screen, will also be visible. So that's the logic that goes along with the screens I've created for making this logic all work. So the one last thing I'm going to show you, let's go back to our bench and let's enter in an invalid password and see what happens. Okay, you can see we get a message that says invalid password, and then after a few seconds, that should go away. Okay, let's try it again. This time we have a valid password, and our user screen popped up because we're at the user level, and we're counting down on our logout. Okay, hopefully this particular project will be useful to you to see the techniques that I used that you'll be able to use in your next project if you want to protect screens and or objects or operations for your next Micro OCS project. That wraps up our topic for today, and let me tell you about a new giveaway we have going right now. Anybody watching here, if you have recently implemented in one of your recent projects an Excel Prime, a Canvas, or an OCS.io, if you submit a case study for one of those projects, or one of those products, I should say, and it's accepted by our marketing team, we'll give away or give you a free controller. Okay, and you could use that on your next project, or you could have it on your desk, so you could use it for development purposes or for demonstration purposes. However you want to use it, that would be your call. So don't miss this opportunity with an Excel Prime, Canvas, or OCS.io application to earn a free controller. All right, don't forget to sign up for training. We've got training classes coming up in the 2nd and 4th quarters. Get your spot reserved. Now, we are starting trade show season. So that means you're going to be able to see us in all kinds of different locations all over the country during the 2nd quarter of this year. From April through the middle of June, you can see all these different places where you can see Horner products and talk to the Horner team. If you'd like to interact with Horner Automation, you can do so online in a lot of different ways, including our website, our YouTube channel, as well as on LinkedIn. Now, next week, we have another user-requested topic, and that is we're going to show you how to perform and how to build custom splash screens for your Horner OCS. So regardless of which OCS series you're using, from the Micro OCS all the way through Canvas, we're going to show you how to create your own custom splash screen and load it on your OCS. If you haven't subscribed to our channel, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so until next week when we make a big splash, let's all get out there and do some good.